All right, this video is about using an area model to represent and then solve multiplication of a fraction by a fraction. There's a little small drawing here, and starting a long time back in students' education in elementary school, they should be understanding that an area is a two-dimensional space that has a length on one side and a length on the other. A length on one side can be called the dimension because that's where it's two-dimensional. But a length on one side is also being taught as a factor. So 3 is a factor and 5 is a factor. A factor times a factor makes a product, or a dimension times a dimension makes an area. So the area here is 15. And of course how that's coming up with is that there would be 3 rows of 5. So if I were to draw boxes in this, which is well back of where 5th graders are supposed to be, that this would be 3 rows of 5 and there would be your 15. And of course this would be true with any sort of area. Any size of area, any size of factors and dimensions. So when it comes time to learn to multiply fractions, fractions and the area model work really well to back each other up. And students in middle school are going to be expected to use area models in order to understand how fractions are multiplied, but then also they go beyond and they start to use them for division. And of course later on when kids get into advanced algebra and things like this, area models can be related to the multiplication of binomials and polynomials and things like that. So it really is important that students learn this, even if there are time-tested ways that are algorithms that kids learn or have learned how to do multiplication in the past. So the students are going to see a worksheet like this, and there'll be a word expression up here, 1/2 of 2/3. They need to understand that the word of always means multiply. And then they need to write this so that it's 1/2 of 2/3. Okay. Over on this side we have a blank area, and what's going to go on is the students would, just like that one that I showed on the previous page there with 3 times 5, they'd have 1/2 and they would put 2/3 up here and they would be multiplying them, and this is the area. Now it's a little different than the other one because the boxes and so forth might be different shaped, but they still need to be thinking about dimensions of the area, and the answer of this problem, this answer right here, is going to be the area inside the box. So first of all, students are expected just to neatly be able to draw a box. In this case it was drawn for them, but this down here they're going to have to draw it for themselves. And they should, as accurately as possible, whether they use a ruler or they're just expected to be neat, to cut it in half in this case. In the other direction it's 2/3. What I like to do for students is when I teach them if it's ever an even number denominator, that means you're going to cut, your first step is to cut the dimension in half. If it was 4, you'd cut it in half, and then you'd cut each of those in half to get fourths and so forth. If it's an odd number like 3 or 5 or 7 or 9 or any of those sorts of numbers, I always teach students to take their finger, or sometimes their hand if it's a big space, put their finger in the middle like this, and then to draw a line on each side like this, and in that way you've made 3 equal spaces pretty easy, and you're thinking about 1, and I can just balance the images on the other side. So if I had half, I kind of did this a little bit too fast. I should have just shown 1/2 like this and taken one color and shaded 1/2 all the way across, and then 2/3 I would show going a different way. So in this case 2/3 would be like coloring like this, and the answer to this problem is going to be represented by the overlap of the 2 colors. So in this case it would be this space here and this space here out of all of the spaces of similar size and shape or similar area. So you can see here that I have this space and this space with overlapping colors, and that represents 2 out of the total 6 spaces inside of this area. So the answer here is 2/6. Of course, eventually what they're going to have to learn how to do is that if you multiplied 1 times 2 you got 2, and 2 times 3 you've got 6, and so the answer is 2/6, which can also be reduced to 1/3 because this space here would be equal to this space and it would be equal to this space here. So that's how this model represents the traditional algorithm as well. and once they get a little hairier, it's still going to hold true. So I'm going to move on to the second sheet I have, which is all of these include unit fractions, so 1/5 of 1/4, 1/4 of 1/3, and so forth like that. But when it gets to be so that they are non-unit fractions, 2/3 and 1/3 and 2/5 and 3/4, then it might be a little bit trickier. So I'm going to go ahead and pick number 5 because it's a little bit different. This has a unit fraction right there, and I want to use 2 non-unit fractions in this case. So 2/5 of 3/4, 2/5 of 3/4. Now, if students want to, and if they're ready, we can do things like we could cross cancel. How many 2's go into 2? 1 of them. How many 2's go into 4? 2 of them. And multiply across, and this is going to be 3/10. We can predict that's going to be the answer.